We'll look at example problem number 50 on page 113 of the textbook. It's in chapter 6 on momentum. The question reads, does a defensive end with a mass of 120 kilograms running at 6 meters per second have a larger or smaller momentum than a running back with a mass of 100 kilograms running at 8 meters per second? So here's our problem solving method, or we're being asked to find how the momentum of the defensive end compares to the momentum of the running back. Is it greater than, less than, or equal to? So that's what we're asked to find. And what's given? Mass of the defensive end is given as 120 kilograms. Velocity of the defensive end. These are positions in American football, if you're not familiar. Is 6 meters per second. The mass of the running back is 100 kilograms, and the velocity of the running back is 8 meters per second. Now, the relevant equations we're going to use are momentum equals mass times velocity. And average force, external force, times WT equals change in momentum in the system. So those are the equations we're going to use in this chapter. So the equations we're going to use here are the definition of momentum. The momentum of the defensive end is equal to its mass times velocity, so it's 120 kilograms times 6 meters per second, and that gives us 720. Units of momentum are kilograms meters per second. There's no derived units for that. We just leave momentum in units of kilograms meters per second. Or the momentum of the running back is equal to 100 kilograms times 8 meters per second, which gives us 800 kilograms meters per second. So to answer the question, is the momentum of the running back is greater than the momentum of the defensive end. Even though the defensive end is more massive than a running back, the running back is running faster than the defensive end. And the combination of mass and velocity gives the running back more momentum than the defensive end. So what does that mean? If the two of them collide, if the defensive end is running this way and running back's running this way, because the running back has more momentum, the total momentum of the system is in this direction, because the greater momentum of the running back cancels out all of the momentum of the defensive end, and there's still a little bit left over in this direction. So whenever they collide, they're going to move in the direction of the running back. They're not going to move in the direction of the defensive end because the running back has more momentum. So whenever they collide, that's what direction they're going to move in, because that's the total momentum of the system is in the direction of the running back. That's if they collide. I mean, the question doesn't ask that, but I'm just further elaborating on